In problem number 1, we're going to list all the possible rational roots. So using the rational root theorem, I'm going to circle the constant, and I'm going to identify all of the factors of 8. 1, 2, 4, and 8. Then I'm going to look at the leading coefficient, and I'm going to identify all the factors of, in this case, a hidden 1. Now I'm going to go ahead and I'm going to list all of the possible rational roots. 1 and negative 1, 2 and negative 2, 4 and negative 4, and 8 and negative 8. In the past, the only problem that I've seen students make with this is they didn't know how to list factors of 8. If something is a factor of a particular number, that means it divides in evenly. So I take 8 and divide it by 1, I can see it divides in evenly. So both 1 and 8 would be factors of 8. 8 divided by 2, it divides in evenly. Both 2 and 4 are factors of 8. But notice when I divide by 3 or 5, for instance, they do not divide in evenly, and that's why we do not list 3, 5, or in fact 6. Now, with those possible rational roots, we're going to start by using synthetic division, and we're going to test until we find one that works. So I'm going to start with positive 1. If you don't have this paper, take out just a blank piece of paper. There's always blank paper up here to use. There's pencils and pens up on my desk. So the leading coefficients here are 1, negative 3, negative 6, and 8. So 1, x to the third, negative 3, x squared, negative 6, x to the first, and 8, x to the 0. I'm going to test 1, and I'm going to use the pencil in case it doesn't work so I can erase. I drop down the first number, I multiply to get 1, I add down to get negative 2. I multiply to get negative 2, add down to get negative 8. I'll multiply to get negative 8, I add down to get 0. It works. Let me actually darken this in. Drop down and multiply, add down and multiply, add down and multiply, add down, and I end up with 0. Whenever I get 0, it tells me that what I just tested, which is the number 1, it works. If it did not work, I would go and try negative 1, and then 2, and negative 2 until I found 1 that worked. Again, if it works, we get 0 left over. Now it says, use the remainder to factor and solve. So this is my remainder. 0 equals negative 8, negative 2, and 1. There's no x's, 1x, and 2 x's. I made sure that all of these were factorable. Remember, if it would not be factorable, you could use the quadratic formula to solve. And you can still use the quadratic formula if you prefer to do that over factoring. 1 times negative 8 is negative 8. I'm thinking of two numbers that multiply to equal negative 8 and combine to equal negative 2. So they have to be different signs, and the larger number is negative. X minus 4 and x plus 2, I'm going to set each one of these factors equal to 0, and I'm going to solve. So I'm going to add 4 to the other side to get x equals positive 4. I'm going to subtract 2 to the other side to get x equals negative 2. Here are my three answers. One answer is x equals 1, and the next is x equals positive 4, and then x equals negative 2. Here are my three different answers. And now in steps 3 and 4, I'm going to use those. So I'm going to write down 1, 4, negative 2. The order doesn't matter. 1, 4, negative 2. 1, 4, negative 2. So it says, find the sum of the roots. The roots are the solutions you have. These are known as root solutions, or if we graph this, it would be x-intercepts. So the sum means add them together. 1 plus 4 is 5. 5 subtract 2 is 3. You will not have multiple choice for your upcoming test. Product means to multiply. 1 times 4 is 4. 4 times negative 2 is negative 8. Looking at number 5 and 6. So 5 starts with we are going to identify the degree, and it may not be written in standard form. And then after we find the degree, we'll look at the number in front. So this is the degree 6. So it is even. The number in front is negative. So even, negative. Think about end behavior here. Even, negative. Hey, people in back, please be quiet. In back, please be quiet. So if it is even, positive is up on the right and up on the left. If it's even, negative is just the opposite. Odd, positive, up, right, down, left. Odd, negative, up, left, down, right. Okay, let me come back here again. So if I'm looking at even, negative is down on the left and down on the right. So down left, down right would be option C. Okay, let's look at function B. It is an odd degree and a positive leading coefficient. Odd, positive, up on the right, down on the left. You do have to have this memorized. Up on the right, down on the left. Upright, let's see here. Upright, down left is option D. Function C is going to be an odd negative. Odd negative is down on the right and up on the left. Down on the right, down right, up left, option A. Function D is going to be even positive. Even positive is up left, up right, and we can see up left, up right is option B. And last one, notice this is not in standard form. This is even positive, even positive. So even positive is up on the left and up on the right is going to be option B. Okay, now for number 6, we're going to go to -2 to +1, and just know that when you see your test, I was able to shift this over. I don't want you to see the answers here, but notice how I shifted over so you have plenty of room when you're going to graph that. Okay, so I'm going to extend this out real quick before we go through number 6. So let me extend this all the way out. Look on the board right now at multiplicities 1, 2, and 3. Look at the 3 graphs that will remain on the board. So here is at -2, at +1, and we're going to say 4 is way over here. It already tells me it's up on the right. Okay, up on the right, bless you, and it's down on the left. It already provides me that information. Notice that -2 is only listed once. That means it's multiplicity 1, and it just cuts through the x-axis. Notice that 1 is listed once, which means it just cuts through the x-axis. 4 is listed once, it just cuts through the x-axis. Okay, let's go on right now to number 7. Please find number 7. 7, 8, 9, and 10 are all related. Okay, we're going to start by doing the same thing we did in number 1. We're going to list all the possible rational roots. Factors of 15 would be 1, 3, 5, and 15. Factors of the leading coefficient, which is 1, is just +1. So 1, -1, 3, -3, 5, -5, and 15, -15. Okay, coming off to the side, doing the same thing that I did in number 2. I'm going to start by testing number 1. So x to the first, x to the second, x to the third, x to the second, x to the first, and x to the 0. So all places are taken care of. I drop down and I multiply. I add together and I multiply. I add together and I multiply, and this does not give me 0. That means 1 does not work. Okay, let's try -1. Okay, again, I have 1 for x cubed, -7 for x squared, 7 is x to the first, and 15 is x to the 0. So I drop down and multiply, add down and multiply, add down and multiply, and it works. What does that tell me? It tells me that -1 is one of the 3 different solutions or roots. Then it tells me to use factoring as a way to solve. Remember, if we can't factor, you can use quadratic formula. Quadratic formula is always an option. What multiplies here? X to the second, x to the first, x to the 0. So I just drop down each one. Again, the first value to the left of the equal sign is no x's, 1x, and 2x. What multiplies to give you 15 and combines to give you -8, -3, and -5. X minus 3, x minus 5 equals 0. Set each one of these factors equal to 0, and we get x equals 3, and we get x equals 5. Here are my 3 roots, -1, 3, and 5. Let's flip over to the back side. -1, 3, and 5. Can you give me 1 second? If you found a mistake for me, just tell me. Okay, give me 1 second, and then I'll answer. So I want to find the sum. That means I'm adding these together. So -1 plus 3 is 2, and 2 plus 5 is 7. And then I'm multiplying them. -1 times 3 is -3, and -3 times 5 is -15. Okay, I'm going to graph. Remember, my roots were -1, 3, and 5. -1 is listed only one time. 3 is listed just one time. 5 is listed just one time. What you have to know is this. If I flip back to the side, it tells me this. It will not tell you this It will not tell you this when you actually come to your test. So you have to know that you're working with an odd degree, and leading coefficient that's positive, which would mean it's up on the right and down on the left. There's -1 is listed one time, multiplicity of 1. 3 is listed one time, multiplicity of 1. 5 is listed one time, multiplicity of 1. And we could see that the y-intercept would be up at 15. I should have gone higher, but this is just fine. Okay, let's list all the possible rational roots of 20. So again, let's list all factors of 20, 1, 2, 4, 5, 10, and 20. And now all the possibilities of the leading coefficient, which is 1, and the only factor is 1 itself. So I could do positive -1, positive -2, 4, 5, 10, and 20. On this part of the test, it's going to say step 1, use synthetic division and test x equals 1. That's what it's going to say. So we're going to put a 1 down and an x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. It's going to specifically say step 1, test x equals 1. Okay, so I'm going to do that. Drop down and multiply, add down and multiply, add down and multiply, add down and multiply, and it works. Step 2 is going to specifically say, you should be doing this with me, guys. You should be doing this with me since this is different than I provided you yesterday. Step 2 is going to specifically say, there's only 3 steps to this. Step 2 is going to say, use the results from step 1. These are the results. And now test -1. So I'm going to test -1, and I'm going to use these results, what's left down below. So x to the 1st, or so x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. So I'm going to test -1. It's going to tell you to test -1. Drop down and multiply, add down and multiply, add down and multiply, add down. And step 3 is going to tell us, in step 3 it's going to say, use the results to factor and solve. So 1, 1, -20 equals 0. No x, 1x, and 2x's. Step 3 will say, use the results to factor and solve. What multiplies to equal -20 and combines to give us +1? And the answer would be 4 and -5, actually +5, -4, right? Okay, looks like my math. So now I'm going to go into x plus 5 and x minus 4 equals 0. Set each of these factors equal to 0 and solve. And in doing so, I get one answer of -5. And I get another answer of +4. So what are my solutions? I should have 4 of them. 4 solutions. Here's one solution, a second solution, a third, and a fourth. So there's going to be a place where you put your answer. X equals 1, x equals -1, x equals -5, and x equals +4. With all of this work, I don't even take time to even try to grade it. I just count it wrong. Okay, it's going to tell you step 1, test 1 using synthetic division. It's going to tell you step 2, using the results, test -1. Step 3 is going to say, now using the results, use factoring to solve. Okay, let's go down to the very, very end, and I'm going to make myself a nicer graph. Again, yours is in the middle. My apologies. What you see on the board will remain there as it applies to multiplicities. How many times do we see -4 listed? 1. So look on the board. Multiplicities that only are 1 just cut through. So 1, 2, 3, and 4. So it's going to cut through, and notice it says on the right go up, and on the left, see, up on the right, up on the left. So it's going to cut through just like this. Okay, at -1, it's listed twice. What does a multiplicity of 2 look like, guys? It is going to bounce off. So it comes, it bounces off. Multiplicity, it's listed 3 times. So a multiplicity of 3 at +2 is going to snake through, multiplicity of 3. So it comes up, then it's parallel, and then keeps going up. Okay, let's look at our last one. I'm going to make dots at -4, 1, 2, 3, and 4, at 0, and at 1. This one says down on the right and down on the left, so they're going to go down in both directions. -4 is listed twice. That means it has a multiplicity of 2. Multiplicities of 2 are going to bounce off. 0 is listed once, so it's going to go through. And 1 is listed once, so it's just going to go straight through.